All right, welcome to the Explainer. Today, we're jumping headfirst into the world of wastewater operations. We're going to take what's basically a dense Q&A cheat sheet and break it all down into a clear, visual guide for one of the most vital and often unseen jobs out there.
Okay, so here's the game plan. We're hitting 5 critical areas, and we're kicking things off with the most important one, staying safe. After that, we'll get into the nitty-gritty, the science of the sludge, what keeps the plant running, and all that crucial lab work. Ready? Let's jump in.
Yeah, before we even think about the science or the mechanics, let's talk about priority number 1. And that's making sure everybody goes home safe at the end of the day. In this kind of environment, safety isn't just a rule book, it's everything. So let's put you on the spot for a second. Imagine you've got to repair a pump. You have your tools, you know exactly what needs to be done, you're ready to start the whole lockout/tagout procedure. But wait, what's the absolute first thing you have to do?
It's not grabbing a wrench or pulling a switch. Nope, it's all about communication. You have to alert the operator on duty first. Why? Because just shutting something down without warning can throw the entire plant into chaos, or worse, get somebody hurt downstream. It all starts with talking to your team.
And safety isn't just about the big machines. It's also about taking care of your own body. These 3 things right here, they might seem basic, but they are absolutely crucial. Lift with your legs, not your back. Make sure floor coverings are secure so you don't trip. And seriously, get out of those work clothes and shower before you head home. You're working with some nasty stuff all day, and you don't want to bring it home with you.
Okay, this number right here, burn this into your brain. 19.5%. When you're talking about confined spaces like manholes or tanks, if that oxygen level dips below 19.5%, you are in a life-threatening situation. That air has been pushed out by other gases, and it can knock you out before you even know what's happening. This isn't something to mess around with.
And it's not just about the air quality either. You never go into a confined space alone. The rule is you need a team, at least one attendant and one supervisor outside ready to act. And another thing, if there's any chance of flammable gases, you're only using tools made of a non-sparking alloy. The last thing you want is to create a spark in that environment. Let's be real, wastewater plants are loud. So here's the deal, if the noise averages more than 85 decibels over an 8-hour shift, hearing protection has to be available. Simple as that. Protecting your hearing isn't just for today, it's an investment in your health for years to come.
All right, now that we've got the safety fundamentals down, we can really get into the core of the job. And that's understanding what we're actually dealing with. This isn't just waste. It's a really complex, living ecosystem that we have to manage.
Yeah, so this term, mixed liquor, it sounds kind of strange, right? But it's actually the heart and soul of the biological treatment process. Don't think of it as just dirty water. Think of it more like a giant, carefully managed soup, just teeming with billions of tiny microorganisms. These are our little helpers, and they're the ones doing all the heavy lifting to clean the water.
And what I love about this is how you can tell so much just by using your eyes and your nose. Healthy sludge, it's going to be a nice light brown color, and it'll have this kind of mild, earthy, musty smell. But if you see it turn black and it starts smelling like rotten eggs, well, that's a huge red flag. That tells you your system has gone septic and you've got a serious problem on your hands.
This brings us to a super important concept, the F to M ratio. That's food to microorganism. It's that fish tank analogy again. You've got to have the right number of hungry fish, our microorganisms, for the amount of food, which is the waste, coming in. Getting this balance just right is one of the biggest challenges for an operator, and it's absolutely key to making the whole process work efficiently.
Okay, so how does all this fit together? Let's actually follow a drop of water on its journey, right from when it comes into the plant as influent to when it leaves as clean effluent. It's a pretty amazing multi-stage transformation. So it all happens in a logical order, like an assembly line, but for cleaning water. First, you've got to get the big stuff out, rags, plastics, you name it. That's screening. Then you let the heavy stuff like sand settle out. That's grit removal. After that, gravity takes over in the clarifiers to settle out the organic solids. And then, once all that's done, we unleash our army of microbes for the biological treatment. And for the grand finale, disinfection to make sure any remaining harmful bugs are zapped before the water goes back to the environment.
And that last step, disinfection, really highlights a big shift happening in the industry. For a long time, chlorine was king, but now ultraviolet or UV radiation is becoming super popular. Why? Because it's incredibly good at neutralizing pathogens, but you don't have to deal with the major safety headaches of storing and handling huge amounts of chlorine gas.
Now, none of this incredible science happens without some serious hardware. This whole process depends on heavy machinery that is running 24/7. We're talking pumps, blowers, valves, and keeping all of it running smoothly is a constant, non-stop battle for the entire team.
And you've got to know your pumps because you use different tools for different jobs. You've got your centrifugal pumps, those are the workhorses, right? They're for moving huge volumes of water. But when you need to pump thick sludge or add chemicals with real precision, you need a positive displacement pump. It moves a very specific amount of liquid with every single rotation.
Okay, another pop quiz. You walk by a pump and you see a slow, constant drip coming from the packing seal around the shaft. That looks like a problem, right? Your gut instinct is probably telling you to grab a wrench and tighten it up to stop that leak. Makes sense, doesn't it? But the correct answer is to do absolutely nothing. And this is a huge lesson. That slow, controlled drip is actually there on purpose. It's designed to be there to lubricate and cool the pump shaft. If you go and over-tighten it, sure, you'll stop the drip, but you'll also cause the shaft to overheat, and you could be looking at a catastrophic failure. Sometimes the obvious fix is the worst thing you can do.
And that's what maintenance is all about, learning to spot these little red flags before they turn into giant disasters. A bearing temperature that's slowly creeping up, a pump that's just not moving the amount of water it's supposed to, a valve that's getting stiff. These aren't just minor annoyances. They are warning signs telling you that you need to take action now.
So, the final piece of this whole puzzle is the lab. This is the quality control department. It's where operators prove that the process is actually working the way it's supposed to. And, maybe just as important, it's where they generate the data to prove to the regulators that they're meeting their legal requirements.
And in the lab, precision is everything. There's no room for close enough. The procedures have to be followed to the letter. Take a pH sample, for instance. There's no hold time. You test it immediately. Or for a total suspended solids test, that drawing oven has to be at exactly 104 degrees Celsius, give or take just 1 degree. This level of detail is what makes the data rock solid and legally defensible.
And yeah, let's not forget, this isn't just a science project, it's the law. The Clean Water Act is the federal rulebook that governs everything. And that simple-looking document, the chain of custody form, it is arguably the most important piece of paper in legal reporting. It's the unbroken trail that proves your sample is exactly what you say it is from the moment you collect it to the final analysis.
When you think about it, this whole incredibly complex system is working 24/7, mostly hidden away beneath our feet. So, what happens if it all just stops? Well, modern life as we know it grinds to a halt. The work wastewater operators do is almost invisible to most people, but it is one of the absolute cornerstones of public health and environmental protection. It's the unseen science that makes our world possible.